Hey everybody, welcome to activity 6.2, graphs that show how a ball moves. And if you're thinking, well, hey, wait, that was the title of the first one, 6.1. No, 6.1 was graphs that show when a ball moves. So what we're going to do is we're going to take it a step further in activity 6.2. If you remember earlier on, and these are the graphs that we got from 6.1, all we did was take a look at, is a ball moving? Is it not? And we added time to it. But what we're going to do is we're going to take it a step further. So our learning target is we're going to learn how to draw and read graphs that describe how an object moves, and we're going to take it a little bit further than we have in the past. So again, if we go back to Newton's cradle, we're going to complete activity 6.2 today, and it involves Newton's cradle as well. Now, if you look at the procedures will tell you your teacher just showed you how to make a motion graph for ball A, the ball that the teacher lifted and then dropped. That shows how the ball moves, not just when it moves. So we've done that. And before you create a graph for ball E, we're going to do a practice. So later on, if you look in your book, it'll say working together with a partner, draw a similar kind of graph for ball E. We're going to practice first, and we're going to practice by creating ball A. So if you want to do this off to the side, if you look in your, if you want to do it on a sheet of paper, you can. But if you go into your book, so let's go into the book for a second. So if you look at your book, all it has is this right here, and it says you're going to create a graph for ball E. There is no room for ball A. So if you want to draw this on another sheet of paper, you can. If you just want to watch what we're doing, you can. It's really up to you, whatever you feel most comfortable with. So let's go back to the presentation. So here we are, and again, this is just practice. You don't have to put this one in your book. So what we're going to do, we added time in our last one, but now what we're going to do is we're going to add the location of where the ball is, and that's going to be in centimeters. So when you look at this right here, what I've done is I've added a ruler to the bottom of it. We know that when we picked up ball E, it took a half a second to go from here to here. Now what we're going to do is we're going to talk about how far did it move in that half a second. And then later on, you're going to create a graph for ball E. So let's look at this right here, and this is where we're going to do the practice. Now let me grab a pen from up above, and let's take a look at it. So we know that from here all the way down is 0.5 seconds. Again, we talked about in the last video, we talked about in physics sometimes you need to have simulations that have set scenarios. So we're always going to assume it takes 0.5 seconds. Now, in the real world, friction would slow that down. But we're not going to worry about that. We're going to assume there is no friction. So when the ball hit here, we know then it took a full second to go up because it took 0.5 seconds to go up. But then it took another whole second or half a second to come back down. So the next time ball A moves, it'll go all the way up and all the way down. So then it would be a full second. That's why these lines are different. So if we look right here, and again, if I draw this down, we're going to know that ball A starts out at 0. And it took a half a second, if I used a ruler, it took a half a second to move 6 centimeters. So I'm going to try and draw this on that half second, and I'm going to draw that line. It's not quite straight. You can use a ruler if you need to. It might do you a little bit better. It might help you out a little bit more. Although if you're going to do it online, you're not going to have access to a ruler either. So what happens next? So ball A hits. It took a half a second to move 6. What's going to happen for the next second? Well, ball E goes up and it comes back down. Well, ball A doesn't move at all for a full second. So I'm going to put a dot above 1.5 because it's 1/2 second to 1, another half second here. So for a full second, it's not moving. So then what happens? Ball A moves again. It takes a half a second to move all the way up here, which is back to 0. So when I look at my location chart, I'm going to go out a half a second. I'm going to put a dot there, and I'm going to try and draw a straight line there. So it takes a half a second to go all the way back out, and it moves 6 centimeters, and it takes a half a second to move the 6 centimeters back. So I'm going to go above that next half second mark, and I'm going to draw a line, or put a dot, and I'm going to draw a line up there. So then what do you notice? The same thing happens. Ball E takes a half a second to go up and a half a second to come down. So ball A, for a full second, so if I'm here, so right now I'm at here, so I got to go out a second. So for a full second, it's not moving at all. So then what happens? Well, it repeats itself. For a half a second, it goes back to 0, and it takes a half a second to go back all the way out to 6. And then it repeats itself. So that's how you would draw this. All you have to do is look at, okay, what's moving and how far is it moving? So if I look for the answer key right here, you can see that we drew it correctly. And if this time would go on forever because it's a simulation and we can just assume there's no friction, it would keep going up, down, up, down, up, down, up, down. So do you have any questions about this? Make sure if you're in class, you ask your teacher. If you're at home, email your teacher. See if they're able to help you. Or the next time you see your teacher, make sure you ask them questions about it if you don't fully understand it. So now what we're going to do is we're going to try and draw a ball E. So what I want you to do with a partner, if we're in school, you can work with a partner on this. If you're at home, you can still work with a partner. You can, there's all kinds of ways you can message each other. So what we're going to do is we're going to try it, but now we're going to try it for ball E. So in the first time, we practiced for ball A. Now you're going to do ball E. For this one, open up your textbook to activity 6.2, and this is what you're going to put in the draw. So when it wants you to draw it, this is what you're drawing there. So go ahead, pause the video, and complete ball E. When you come back, we'll talk about what you have. So hopefully you pause this for a few minutes while you created the graph. So how is this one going to be different? How is it going to be similar to what we've done in the past? Now the first thing you have to ask yourself is, okay, so if we lift up A, and A moves for that half second, does it come down? What is ball E doing for that half a second? If you thought to yourself, well, ball E is not moving for a half a second, you're right. And if you look at the ruler here, it's at 10. So for a half a second, I'm going to put a dot above the half second line. Right here, I'm going to go to half second. For a half second, it should not be moving at all. It's not moving. Then what happens? It goes from 10, it takes a half a second to get out to 16. So it takes 0.5 seconds. So if I'm at 10, I'm going to go to that next one. It's a little bit harder because it's way up here. I'm going to put a dot on the 16, and I'm going to draw that line up. Then what does it take? It takes a half a second to come back down. So I'm going to go, so if it's started moving at 0.5 seconds, when ball A hit over here, now it goes up to the 16 for half a second and it comes back down. So I'm going to try and put that dot right here. So I'm going to draw it like this. So then now ball A goes up and it comes down. For that half a second it goes up and half a second it comes down. Is ball E moving at all? You might tell yourself, no, it's not moving. It's perfectly still. So I'm going to put another dot 1 second out because a half a second for ball A to go up, half a second for it to come back down. So what happens? Well, ball A comes back down. Now ball E goes up for a half a second, comes back down, and it goes from 10 up to 16. So again, let's see if I'm right here. So I should be here. Then I drew it for a second. So now I got to go above the 3, and I got to get back out here to the 16. And I'm going to draw that there. And I'm going to go above here. So again, it's harder to judge that. If you can put like a little piece of paper up to the screen to help you out, you can. So then for a full second, it's going to stay put. Then what's it going to do? It's going to go out for a half a second, and then we're running out of space here. So that's what it should look like. So if we look at the answer key, it's going to look like this. The only difference is we actually took it out one more time and started this upward movement that we have here. But does this make sense? Where ball A was moving at first, ball E is not. Ball E is right here while ball A is being dropped. Then ball E moves. And then you have to look at the distance. Now the expectation is that you're able to do this on the test. You're going to have information. You're going to have to be able to either A, interpret the graph. If we give you a full graph, can you read the graph? Do you know what's happening? Can you answer questions? Or we may give you the data or the scenario and you have to create the graph. So make sure you have really good notes here. And what I mean by notes is make sure you have this down in your book so you know exactly what to expect and you have an example and you can look at it. All right. So we've already watched these videos in class, so you won't have to watch those again. Again, as always, if you have any questions, make sure you ask your teacher. Thank you.